Hello and welcome to another day of Advent of Code. This one is day 8, and this one was a lot of reading, so hopefully I'll be able to simplify the problem a little bit for you, because I found the problem pretty hard to read, and, well, it wasn't hard to read, there was just a lot to keep in your head, so anyway, let's jump into it. Okay, so the problem that we're going to see today is we're going to have a bunch of these input rows, and now this is something that I missed from the reading as well. The rows have an extra new line in them in the sample input. So this is not actually what the input will look like, but it'll look more like something like this. Input s dot replace pipe new line with just the pipe. And I think they actually didn't have this extra space there either. But double check your actual input versus the sample input and make sure that when you're puzzling out the sample input that you have the actual same content, because otherwise that can throw you off. Right, but in the input, the I'm gonna call these rows, and I'm gonna call other things lines. So again, real confusing, rows and lines. So this is one row, and the row is split by a pipe, and on the left hand side it has the input side, and on the right hand side it has the output side. Now on the input side, there will be 10 chunks of string, and the chunks of string have letters A to G, and those represent electrical lines that are going to power parts of a digital clock. And in this example, they're marked A, B, C, D, E, F, G in order, but they will not be in order in your puzzle, and they will be different per line. Now, whatever the lines are set here is different than this row here, is different than this row here. And what you'll do is you'll use the inputs to figure out which chunk of characters represents each individual number in the output lines. So you'll be able to use, because all 10 of them are specified here, and there are some tricks to figure those out. But fortunately in part 1, you don't have to actually figure any of that out, and it gives you a hint for starting to figure out part 2. So in part 1, it says you can uniquely identify some numbers by the number of lines set, and these are the 4 numbers that are unique. So if we look at these numbers here, we grab 1, get over here, you'll see that 1 only has 2 lines set, 4 has 4 lines set, 7 has 3 lines set, and 8 has all of the lines set. And so these have a unique number of lines set. There's no other that has 2, 4, 3, or 7. Those are the only ones that are set there. So that makes it easy to identify these, and so it's just kind of a hint there. I'm going to write part 1 out here, and then we're going to talk about part 2. I'm going to kind of show you my code approach. We're not going to write that one live because it's a little bit more complicated. All right, so for line in input s dot split lines, we need to only look at the output for part 1. Another easy thing to miss when reading. Output equals line dot split on the pipe character, and then parts equals output dot split. And we're doing a lot of splitting, and we want to count the number of 1, 4, 7, and 8. So count equals 0, and then for part in parts, if len part is in, the 1, 4, 7, and 8 have lengths of 2, 4, 3, and 7. 2, 3, 4, 7. 2, 3, 4, 7. Then count plus equals 1, and then at the end we print that count. And I forgot to write down the expected value. So we're gonna have to check that real quick. But we get 26, and I seem to remember that as right. A8 part 1 dot pi. Yes, the expected is 26. Cool. And you'll see mine looks very similar to that, although I actually just kept track of all of the parts instead of doing it here. This is a little bit faster. But this was me scrambling to read the problem. Okay, so that's part 1. In part 2, we need to figure out what the numbers are per line, and then sum the digits in the output. So this is a 4-digit number. And so to do that, what I did is I tried to pick out numbers that are unique. First, what I did is I figured out which ones have length 6 and which ones have length 5, and separated those out. So 9, 0 and 6 have length 6. And these 3 have length 5. So from that, you can do a little bit of figuring here. Let's just clean up the extraneous. Well, it's still gonna trigger someone's OCD here, so we're just gonna figure this a little bit better. Oh, it's bothering me, so I'm just gonna fix it. This one's messed up too. Anyway, so you can separate the ones out that are length 3 versus length 5, and that helps you differentiate a little bit here, but then you have to get a little bit clever. The next number that I tried to figure out was the number 6 here, and the reason, or the way that I could differentiate it from 0 and 9 is based on this left-hand side here. And again, we don't know what the left-hand side is, we just know that this one is missing one, and this has both of them. Fortunately, we can overlap it with this over here, since we know this has both of the left-hand side. So if we were to intersect these with 1, 6 would only have a partial overlap here. That's how I figured out 6. That gets us 6 figured out. Well, we have these figured out now. All right, so once we have 6 figured out, I was looking again for overlaps from ones that we know. And if we look at 0 and 9, the 4 has a different overlap between these two. In the 9, it will have this. In the 0, it will not. So from that, we can find either 0 or 9. Once we found 0 or 9, we know we only have one length 6 left over, so we figured out 0. Then we need to go over here. And what I used to find 5 is I overlapped it with 6, and it should be the same as 5, so we should still see the same number there. That's how I figured out 5. So we've got that. We're good here. And then between 3 and 2, we again see this left-hand side, so we can overlap 3 with 1 and figure that one out. And then there's only one left over. And so that's how I figured that out. Now, of course, I did this in code, and so it's a little bit more complex than just visualizing it. But that's how I went through and figured out each of the numbers. Now I'm going to show you my code, which is maybe not the most interesting, but goes over the concept in a little bit of detail. A8, part 2, y. Okay, so there's a lot of code here. And another thing that I noticed that I forgot to mention here. Oh yeah, lines aren't always in the same order. So even if you see a line like C, B, D, G, E, F, it might not be in this same order over here. So you have to make sure that you sort the characters in each chunk. Make sure that you're comparing them properly, which is what I did here. I also have this here for some reason. Oh, I know why. Because at the end, I need to figure out the actual digits. Okay, so again, we split the line into 2 parts, the start and the end. I keep the end parts around because I'm going to use them later to figure out what the actual digit is down here. Then I get the total set of digits. I could have just used the input. I didn't need to put the output in here as well. After reviewing the problem and learning a little bit more about how it works, I sort the internal parts. This is a key mistake that I was making early on. Otherwise, sometimes your set will be too big. And then from that, I basically just build up a mapping where I figure out the length. So this is find the digit that has length 2. This little trick here, I did in another video, so I'll link that in the description. Basically, it's make sure there's exactly one thing in this right-hand side and then assign it to whatever this is. So we do that for our 4 numbers. Then we figure out whatever the length 6 things are. I'm able to find 6 based on its overlap with 1. I'm able to find 9 based on its overlap with 4. Then 0 is the last one that's left over that doesn't have any overlap. Then from the length 5 ones, I overlap 5 with 6 and see what it does. I overlap 3 with 1 and see what it does. And then we have our leftover number. Once we have that mapping, we invert the mapping. So I was doing number to string. This is now string to number. And then from that, I can find the 4 digits, multiply them by a power of 10, and then add that to our total. So that's how I did part 2. But yeah, this one's a very visual problem. So I recommend trying this out in Paint or figuring that out, similar to how I did. Anyway, I'll see you around for the next day.